Hey everybody, in this video we will talk about the volume of prisms. In the next video we will talk about the volume of cylinders. Volume is the number of cubic units contained in the interior of a solid. So when we write our answers, those answers will be in cubic units or units cubed. Okay, a couple more things about volume before we get to volume of a prism. Volume congruence postulate. If two polyhedra are congruent, so they are exactly the same size and shape, then they will have the same volume. The volume addition postulate says that the volume of a solid is the sum of the volumes of its individual parts. So what that means is if you have a solid like this and you want its volume, you could find the volume of this part and add them together and you'll get the volume of this entire solid. So the volume of a prism is found by this formula, capital B, H. When you see a capital B in the formula, that means the area of the base. So capital B is area of base, and H is for the height, which is the distance between the bases. Okay, so capital B, area of the base, times height, the distance between the bases. So here is a prism. This one happens to be a rectangular prism. In a rectangular prism, you can use any rectangle on here as the base. So if I choose to use this bottom as the base, I would find the area of that base. Then that would mean the top is also a base, and the height would be the distance between them. If I used the left and right as the bases, then the height would be here, the distance between the left and right base. So here I have a prism. This is a hexagonal prism. Okay, so the bases are hexagons. When I have a prism that has any part that is not a rectangle, I must use that as the base. So this has a part right here that is not a rectangle, so I have to use that hexagon as the base. If I have a rectangular prism, like this one, everything on it is a rectangle. I can use any part I want as the base. Here's one that's got a triangular base. The triangles are not rectangles, therefore I must use the triangles as the base. Okay, now there's a couple of shortcuts that we can use. If we have a rectangular prism, because anything can be the base, to find the volume, I can just do length times width times height. Okay, so that's a quick way to do the volume of a rectangular prism. And then in a cube, because the length, width, and height are all the same, I can take the side length and cube it. So the side to the third power, that's the same as length times width times height if all the sides are exactly the same. The last thing we'll talk about before we start finding volumes is Cavalrys Principle. Cavalrys Principle says that if two solids have the same height and the same cross-sectional area at every level, then they have the same volume. So what that means is that if I have an oblique prism, I can find its volume just the same as a right prism. So all of these prisms that I have here are right prisms. Okay, now if I just slant it like this, it does not become an oblique prism because every lateral side is perpendicular to a base. Okay, so just tilting it like this does not make it oblique. Okay, but if I have a deck of cards, and I know there's rounded corners on this, so it's not technically a prism, but we'll say that this is a rectangular prism. Okay, and I'm going to zoom out so we can see this a little bit better. Okay, so we've got our rectangular prism here, and it's a right rectangular prism, but if I do this, it is now oblique. It's not right because this right here, this lateral edge, is not perpendicular to the top and bottom base anymore, so it is oblique. Now, making it oblique would change its surface area. So we can't find surface area of an oblique prism the same way we can a right prism, but for volume we can. Okay, so what Cavalrys Principle says is that if I have a right prism, and we'll call this our right prism, and I cut this deck. Okay, so when I cut the deck, I see a cross-sectional area. Okay, so right here's a cross-section, here's a cross-section. The area is the area of one card on the deck. Okay, now when I make it oblique, the height has not changed. And when I do a cross-section, I get exactly the same, and I actually happen to pick exactly the same spot. So I've got the area of a card. Okay, so the height hasn't changed, the cross-sectional area hasn't changed, therefore the volume has not changed. So whether a prism is right or oblique, we can use the same formula to find the volume. So here we have a rectangular prism. Okay, everything on it is a rectangle, so all we have to do in order to find the area or the volume is length times width times height. That's 4 times 6 times 8. The order does not matter because we're just multiplying. Multiplication is commutative, so the order here does not matter. Okay, so I'll do 4 times 6 times 8. So my volume is 4 times 6 times 8, and that is 192. So the volume is 192 yards cubed. Now my next one is not a rectangular prism because there's something on it that is not a rectangle, and that is a trapezoid. So I've got a trapezoid right here, and there's also a trapezoid on the back side, so those will be the bases. So for area of the base, so I'm using this formula right here, area of base times height. For the area of the base, I have to use the formula for area of a trapezoid. So the volume is area of the trapezoid. That's half times the height of the trapezoid, which is 110, times the sum of the bases of the trapezoid. That's 170, and this is 110. 170 plus 110. Okay, so that's how you find the area of the trapezoid. Okay, so really what that's doing is the height times, and then the half times sum of the bases is the average of the bases. So it's the height times the average of the bases. So this right here is the area of the base. We have to multiply that by the height of the prism, and the height of the prism is the distance from one trapezoid base to the other, and that is right here. That is 120. Okay, so I can type this in the calculator now. So it's half times 110 times the sum of the bases, 170 plus 110, times the height of the prism, which is 120, and it's kind of a big number. So we have 1848000, so that's 1,848,000 meters cubed. Next, we have another one that's got something that is not a rectangle, and that is a triangle. So this triangle and the one in back will be the bases. So for the area of the base, we're dealing with the area of a triangle. Okay, so for the area of that triangle, that's half times base and height of the triangle. So down here, I'll use this as the base. That's 14. I know that because of these tick marks. It says that all three of these are the same. They're all 14. Okay, now the height of the triangle is right here. I'm not worried about the height of the prism yet, the distance between the bases. I'm just worried about this triangle. And this triangle has a height that we do not know. But I can use Pythagorean theorem to get it. So I've got a 14 here. Here I have a 7. So I can do leg squared plus leg squared equals hypotenuse squared. That's 7 squared plus b squared equals 14 squared. And I can subtract 7 squared from both sides. So b squared equals 14 squared minus 7 squared is 147. And then I can take the square root. And we'll see if we can simplify this radical here. So we'll get an exact answer. So when I add these digits, 1 plus 4 is 5 plus 7 is 12. 12 is divisible by 3. That means 147 is divisible by 3. 147 divided by 3 is 49. So it's 3 times 49. 49 is 7 times 7, so there's a pair. So B is 7 times the square root of 3. So this right here is 7 root 3. That is the height of the triangle. So there's the area of the base, half times 14 times 7 root 3. Now times the height, that is the distance between the two triangular bases, and that is 12 centimeters. Okay, now I'm going to type in everything but the radical, so I'm just going to get an exact answer here. Half times 14 times 7 times 12 is 588. So I put an A here for area. That's not right. It's V for volume. So I get 588, and I did not multiply by the square root of 3, so I'll have to write that in still. 588 root 3 centimeters cubed is the volume. Next, I have an oblique prism. It is an oblique rectangular prism. The bottom is 8 by 8, and then this right here isn't really part of the prism. It's just extending the base and showing that the distance between the bases is 5 inches. So as a rectangular prism, I can use length times width times height. So it's 8 times 8 times 5. 8 times 8 times 5 is 320. So 320 inches cubed is the volume of this prism. Next, I have another prism that's got something on it that is not rectangular. I've got a pentagon here. So I've got a pentagonal prism. So for this pentagonal prism, I need the area of the base. For the area of a pentagon, I use the formula for the regular polygon, which is 1/2 times apothem times perimeter. So for the area of the base, half times the apothem, which is right here, from the center to a side. That's 4.13. Times the perimeter. Now this is a pentagon, so it has 5 sides. They're all the same, and each side is 6 feet. So for the perimeter, 5 times 6 is 30. So there's half times apothem times perimeter. That is the area of the base. Now we multiply that by the height, which is the distance between the two pentagonal bases, and that is 10. So half times 4.13 times 30, that's half apothem times perimeter, times the height of the prism, which is 10, and I get 619.5. So the volume is 619.5 feet cubed. And the last problem we'll do on volume of a prism, you plan to pour concrete to cover a rectangular region with dimensions of 34 feet by 10 feet to a depth of 3 inches. How much concrete should you order? And we're going to express our answer in cubic yards, because when you order concrete, you order cubic yards. Okay, so 3 inches deep is not a lot of concrete. You're not going to pour a driveway 3 inches deep. You won't be able to drive on that. What this is actually for was a crawl space in a house I used to live in, where we wanted to put concrete on the floor just to make it a little nicer storage. So we wanted 34 by 10, but 3 inches deep, and we had to know how many cubic yards to order. So what that looks like, here is the 10-foot by 34-foot floor, and we wanted concrete 3 inches deep. So it would look about like that. So it's a rectangular prism. Now, everything should be in the same units when we find the volume. And I've got feet, and inches. So let's convert everything to inches. So 34 feet times 12, that's 408 inches. 10 feet times 12, should be able to do this in our head, is 120 inches. Okay, so now the volume, length times width times height, is 120 inches times 408 inches times 3 inches. So we have 120 times 408 times 3. So we have 146,880 inches cubed. So that's the amount of concrete we need to order. But we don't order concrete in cubic inches. We order concrete in cubic yards. So we need to convert this. Okay, so what we want is to know how many cubic inches are in 1 cubic yard. So 1 cubic yard. Okay, so here's a cube. If this had sides of 1 yard, then this would be exactly 1 cubic yard. Okay, now a yard is 3 feet. So if this is a cubic yard, it's 3 feet by 3 feet by 3 feet. Okay, now 3 feet is 36 inches. So it's 36 inches by 36 inches by 36 inches. So in cubic inches, a cubic yard is 36 times 36 times 36. Which is the same, by the way, as 36 cubed. So 36 cubed is 46,656. Okay, so 1 cubic yard is 46,656 cubic inches. We need to fill 146,880 cubic inches. So how many cubic yards are we going to get? We will divide 146,880 by 46,656. And we get about 3.22. But I see that I actually have an error here. This is supposed to be 46 and I put 45. So I'll do that again. 146,880. divided by 46, 656, and we have about 3.15. So we need about 3.15 cubic yards of concrete. Now we're probably not going to call and order 3.15 cubic yards. We'll order 3 cubic yards or 3.5 cubic yards. Maybe they'll sell it as a quarter, so 3.25 cubic yards. So we're going to have to settle for ordering a little bit less than the 3.15 or a little bit more. So we'll have either a slightly shallower concrete pad here or slightly deeper.